Butanol, the future of biofuel. What is butanol? Butanol is an alcoholic compound created by microorganisms which allows us to use it as a fuel source. Aside from being used as an alternative to gasoline, it is also valuable for producing fragrances commonly found in various cosmetic and non-cosmetic products. The source of butanol. Butanol is produced when an anaerobic microbe ferments. The best microbe type for this purpose is the naturally occurring bacterium Clostridium acetobutylacum. When this bacterium is used, it creates the compounds acetone, butanol, and ethanol. The sugars are often provided by lignocellulosic biomass, which is biomass consisting of dry plant matter, as it is the most prevalent raw material on Earth. The cultivation of butanol. To produce the sugars to make butanol, biomass goes through enzymatic hydrolysis to break down the complex carbohydrates into simple sugars. Then a Clostridium bacterium will turn these sugars into the acetylbutanol ethanol mixture. Acetylbutacillum, an anaerobic microbe, doesn't use oxygen to survive and create energy. Instead, it uses anaerobic respiration. Two phases of fermentation need to occur. The first is acidogenesis. In this step, sugar such as glucose is turned into organic acids, which resembles the glycolytic processes in cellular respiration. This is done when the bacteria quickly replicate and produce the acid butyrate, which lowers the pH, making it more acidic, and signals the bacteria to start the second phase, which is solventogenesis. In this phase, the solvent is produced when butyrate, which acts as a substrate, gets synthesized into butanol. This is similar to anaerobic respiration with yeast, where pyruvate gets processed into carbon dioxide and ethanol. The substance then gets filtered using distillation and is later processed to create pure butanol. Butanol is considered an advanced biofuel. However, the process using the Clostridium bacterium is not highly effective. This is because of the low butanol yield that comes with the fermentation, since acetate and ethanol are also produced. For this reason, butanol is still in the research/developmental stage with minimal deployment. Butanol has a positive impact on the carbon footprint as it has high energy density, meaning that it can store a lot of energy in a particular volume, and this density is comparable to that of gasoline. Burning butanol produces fewer emissions than other petroleum-based fuel sources, which reduces environmental pollution. The process of producing butanol from biomass is complicated, consisting of filtration and purification processes, which, when coupled with low yield of butanol from ABE reactions, means that making an industrial plant system revolving around butanol production would be difficult and expensive. However, because of the many steps in the cultivation process, many job opportunities may show up as a reaction to the manpower needed to gather biomass, isolate sugars, produce butanol, etc. This would increase the job market. Additionally, the versatility of butanol would lead to industry usage and, subsequently, public interest would increase, which would foster economic growth. The issue with butanol is that it is still in its developmental stages, so it has yet to be presented to the public in mass. However, Butafactory, a team in Shanghai, conducted a poll in which they inquired about the public's awareness of butanol. The results overwhelmingly showed that 72% weren't aware of N-butanol. The team then made efforts to publicize this compound via the internet to gauge whether the public thinks researching N-butanol is worthwhile, and the results show that 83% of pollers felt that it is necessary to promote the application of N-butanol. From what has occurred so far, butanol has the components to be used as an energy source someday. However, we would need to first combat the issues of low yield and production costs to reach this goal. Some next steps that could be taken are to push the existence and utility of N-butanol heavily to the public via internet ads to get further funding and public interest in making this biofuel usable one day. Showing the public the dangers of carbon emissions by using gasoline would allow them to be on the lookout or at least be more open towards alternative energy sources such as butanol. Additionally, we could push for obtaining biomass through massive agricultural wastage and even encourage genetic engineering on the Clostridium bacterium to produce a higher butanol yield. If funding were not an obstacle, then investment toward obtaining a higher butanol yield would occur, with genetic engineering of anaerobic microbes being pushed. There would also be a rise in butanol plants that work towards bettering the fermentation and distillation techniques to maximize efficiency. Lastly, there would be massive efforts to inform the public of butanol through online ads, campaigns, and other forms of news. Given this scenario, the eventual perfection of butanol would take place, and its usage would be commonplace. And these are some of my image sources that I use on the slides, and these are some of the information sources that are used in my research. Thank you.